Welcome to this presentation on ASA firewall clustering on the ASA5585X SSP60. My name is Keith Brister and I'm a system engineer in the Customer Proof of Concepts labs in RTP. ASA clustering has become very popular because it can scale firewall throughput up to 100 gigabits per second by clustering multiple ASAs together. In this presentation, we will scale a pair of ASAs to show max bandwidth and max connections per second for a pair of 5585 SSP60s. Here we have the ASA PBST clustering test bed. I have a pair of ASA SSP60s that have a spanned Ethernet port channel into a pair of Nexus 7K with a VPC port channel. The client test tools all connect into a Nexus 5K, so we have 8 10 gig ports going into the 5K, which are VPC'd into the 7K. Also, the test tool servers, there's also 8 10 gig ports going into a 5K that goes into the 7K. All my client ports are in the interface in the VLAN subnet, so 1010 network, and I also have a VLAN 100, which is the outside of the ASA. So on the Nexus 7K, I created a VRF outside. VLAN 10 and 100 are in that VRF. The servers are all in VLAN 20. So, and we also have a VLAN 200, which is the inside of the ASA, and I created a separate VRF inside on the Nexus 7Ks. So when client traffic flows in, it comes into through VLAN 10 into the VRF outside and goes across VLAN 100 to the ASA. ASA bridges VLAN 100 to 200, and then traffic flows into the VRF inside, which allows it to get to the servers in VLAN 20. The cluster control links are all cabled into the same Nexus 7K pair. It's all in an out-of-band subnet. So I used VLAN 99 for the cluster control links. So this will be a bandwidth test against a cluster of 2 ASA SSP60s. I'm going to start the test with just one ASA active in the cluster. So 2 ASAs are named Woody and Abby, part of the Psych TV show theme. In the CPOC, that's what we use. We use some themes for all of our device names. So Woody, if I do a show cluster info, Woody is the master and the only ASA in the cluster. I'm starting to ramp up my traffic now. Actually, it's about to start. All right, this is the Spirent Avalanche result screen, and we're using 2 pair of Spirent Avalanche 3100Bs. Each has 4 10 gig interfaces. So from this screen, we're going to be looking at the traffic area here in the middle. This is the client view. So this is the incoming traffic coming from the server, and then outgoing to the server is only about 300 meg. It's just the TCP gets, but the bandwidth coming back. Still ramping up. I have this ramping up to 1,000 SIM users. And we're at steady state now. So incoming, I'm getting about 33 gig with one ASA in the cluster, outgoing about 500 meg. And the TCP connections per second is about 3,900, between 3,700 and 3,900. So let's take a look at the command line first. So if I just do a show cluster CPU, CPU's at about 72%, which is pretty good. And just looking across all the cores, they're evenly distributed, about 72%. You show cluster resource usage. This will just show you, your connection rates, about 3,700, which is what we saw in the Avalanche. Concurrent connections, about 4,000 concurrent connections. So you can see current 4,000, about 3,800 connections a second. I'm going to change to the context, the L2 context where the traffic's flowing. Just do a show traffic here. And this shows the outside and inside interface. It's in bytes per second, so you have to change that, but that's matching up with the 30 gig. So if we open up ASDM here, looking at Woody, you can see here, outside interface is showing about a little over 30 gig, which is matching up with what the test tool is saying. If we get on the system context, CPU showing about the same, around 72% across all the cores. Memory usage is low. This is a connections per second test, so it affects the CPU more than the memory. So we're still sitting about 33 gig, no unsuccessfuls. I'm going to next bring up the second ASA in the cluster. So if we go to Abby, so configuration replication is happening. If we get back on Abby, so Abby now sees, Woody, this is Woody, so Woody's a master and it sees Abby as a slave. So both are up in the cluster, and the bandwidth's starting to go up a little bit. Alright, I'm going to need to add some more sim users here to get the load a little higher. Okay, so we're ramping up now. So we're at steady state 2100 sim users, and we got to about 62 gig incoming and almost a gig outgoing. So 63 to 64 gig aggregate. Try and bump it up just a little bit more. So we're ramping up to 2,520 sim users. And looks like we got about 65 gig plus in incoming. It was about a gig outgoing, so about 66 gig aggregate. And we're up to 7,600 TCP connections a second with almost 10,000 concurrent connections. Back on the command line. So we can see from the cluster summary, that's the 10,000 open connections cons and about 7,600 TCP connections a second, and those are spread across each one of these ASAs, 3,800 each. So it's evenly distributed. And just looking at the packet distribution, you can see the packets per second per ASA are even, and everything is pretty much locally processed on the ASAs. If we look back at the ASDM, you can see that Abby joined the cluster. And Woody, if we look at Woody, still seeing about 30 gig, a little over 30 gig. We're still at about 65 gig, so Woody's seeing about 30 gig, and we can look at Abby. Abby's a little over 30 gig also. We change to the CPOC L2 context, show con. I mean, right now, there's two ASAs, so whatever cons that Abby is owner of, Woody's going to be a director or a backup for. If we do a show cluster info con distribution, you can see Woody he's owner for 3,800 cons a second, but he has a total of 7,600 cons a second because he's a backup. He's an owner for 3,800, and he's a director or backup for 3,800, and Abby's doing the same thing. So our max was almost 66 gig incoming and about a gig outgoing. So almost 67 gig with two ASAs in the cluster, and this is all TCP traffic. Here we'll be testing max TCP connections per second on a pair of ASA SSP60s in a cluster. We're going to start off with one ASA active in the cluster, see what the max is for one ASA that has control plane configuration and it's part of a cluster. Then we'll add another ASA to the cluster. So the test is about to start. So I'm testing with the Avalanche, Spirent Avalanche, and I'm using 64-byte objects. So 5,000 clients will go in, pulling 64-byte object as fast as possible. So it's starting to ramp up now. We're about 200,000 connections a second. 250. 260. Ramp up to 1,000, but I think we're sitting now at 260, so I think we're at our max even though we're going up. So if we look at the CPU's at 100%, so we're at the max we're going to be able to go. Just taking a look at the resource usage. You can see this one ASA Woody has all 266,000 connections a second. And it's about what we're sending. So next, I am going to enable clustering on the second ASA Abbey. Configuration is getting replicated. So both ASAs are active. See the tool kind of backing off during transition. Now it's starting to ramp up. It's 370,000. Started getting some drops. So you can see Woody has a CPU of 95%, Abbey has a CPU of 100%. So if we look at the packet distribution, Abbey's actually, what happened was, the Nexus, the port channel from the cluster to the Nexus brought up Abbey's links, so it now had 4 more ports to load balance to the cluster. So existing connections that were on Woody may have gotten load balanced over to Abbey, so Abbey's having to forward these connections across the control plane. So that's why Abbey's CPU is much higher right now. And if we do so we're getting some forwarded cons still on Abbey, and until those connections finish out, they're going to continue to send across the control plane. So we settle back down about 357,000, which is the marking number for an ASA SSP60, and using the marking numbers for clustering, you should get a 50% in it. So we're seeing that. A few drops. See, CPU still sitting at 100%. So that is the max connections per second we'll see with 2 ASAs. I will now go through the configuration of the ASA cluster PBST. So looking back at the diagram, we have the 2 ASAs, Woody and Abbey, and we have a pair of Nexus 7Ks that have a VPC down to the cluster. The same Nexus 7Ks are also simulating the control plane of the cluster, or the cluster control link. So from Woody and Abbey, you have ports 06, 07, 08, and 09 are on the data link side on both ASAs. It's important that those ports are all the same on the data link side for both ASAs, and 20, 21, 22, 23 on both boxes are going to the cluster control link side. So 06 and 07 both go to the left Nexus 7K, and 08 and 09 go to the right 7K. And the exact same thing going on the second ASA, 06, 07 going to the left, 08, 09 going to the right. On the cluster control side, same thing, 20, 21 are going to the left, and 22 and 23 are going to the right, and we're doing the same thing on the other ASA. So with the show cluster info command, you can see Woody is in the master state and Abbey's in the slave state. Take a look at the configuration. Like we said, 06 through 09 we're on the data link side, and 06 and 07 both go to the leftmost ASA, so we have the VSS ID pointing to, telling the cluster that that's part of a VPC, and that's all going to one Nexus box, and 08, 09 are part of VSS ID 2. So the VSS command is just it's the 6500 VSS, so it means the same thing for a VSS pair if you're connecting the ASA cluster to a VSS pair versus a Nexus pair. So VSS is pretty much for a VSS or a VPC. The 10 gig interface 20 through 23 are all going to the cluster control link, or the backplane of the ASA cluster. Port channel 1 is that cluster control link, and port channel 20 is the data port channel. So I'm showing with a port channel span cluster, we're going to load balance those VSS load balances so that we're evening out the traffic between the two Nexus and the pair. I have two sub interfaces, one for VLAN 100, the other for VLAN 200. These are going to be allocated over to the data link context, which is a transparent firewall. So looking down at the cluster bootstrap configuration, this is the Woody device. So I've local unit is Woody, and we're telling it which interface, which port channel is the cluster control link port channel, and we're giving it this IP, which is part of an out-of-band subnet of the data link side, and I'm giving it .1. The ASAs use this subnet or this IP to talk to each other along the back control plane or cluster control link to pass information back and forth there. Set the priority to 1. This box comes up all with the same time the other box does. Then he's going to become master. And the health check is for the high availability. And when one ASA fails, it knows how long to wait before it can try and check to see if it's available again. And the ASA is enabled. A couple of contexts created here. So we have the admin context, and then we have the this is the transparent firewall context, where I'm allocating the two sub interfaces to that context. So in the admin context, I have a management interface which has an IP address as the physical interface, which is really the IP for the master. So whoever's master is going to take this IP, and then I have a cluster pool, which is a local pool configured here, which has a range of addresses. So if you're trying to get directly to an ASA, you don't care if it is the master or not. You just need to get to a specific one. You can telnet or telnet to these specific addresses here. And priority 1, this ASA is set as priority 1. So that one's going to take the .8 address. Priority 2 will take .9, priority 3, 10, and you can create this pool as big as you need. The logging is all turned on and using the default logging. The HTTP server is enabled for ASDM access, and I'm allowing all devices to connect via ASDM. Rest of configuration is default. All the default inspection is turned on. So in the transparent firewall configuration, we have a context created, and I have two interfaces here, port channel 20.100, which is the outside interface, and port channel 20.200, which is the inside, both part of bridge group 1. So I'm bridging these two VLANs together, and then I have a management IP here for the BVI. We're just permitting IP any, and we have access groups allowing that in and out of all the interfaces. Default inspections turned on. Taking a look at the other ASA. Just look at the bootstrap configuration. So this bootstrap configuration is the only thing that's different among the two ASAs. Everything else is synced from the master device to all the slave devices. So give it the local unit name of Abby. The cluster, tell it the cluster control interface is port channel 1, and I'm giving this one .2. Set the priority to 2. This other configuration is the same and it's enabled. We move on over to the two Nexus, which are Sean and Gus, and using that for the data link and the control link. So we have some VLANs created here. You can see VLAN 100 and 200 are the outside and inside of the ASA. We want these two Nexus to be the root for the spanning tree. So we've set the priorities lower for all these VLANs. And we have a VPC domain here, which is the VPC peer link is port channel 1 between the two Nexus. So I have an interface VLAN 100, which is it's part of a VRF outside, and then I have a interface VLAN 200, which is part of VRF inside. These are part of the same subnet, so since on the ASA I'm bridging VLAN 100 to 200, you can see we're 10.100.02, we're 10.100.098 on 200. So I'm just bridging those on the ASA. So if client comes in on VLAN 10 in the outside VRF and he wants to get to servers, which are the Avalanche servers are here, trying to get to the servers on the inside, well, I have to use this subnet here for the outside interface, go over to the ASA, bridge between that VLAN and this VLAN, then I go through the ASA, come out on VLAN 200, and then I can get into the VLAN 20, which is part of the VRF inside, which is the same as VLAN 200. Port channel 10 is port channel up to the test tool clients. Port channel 20 is going over to the ASA cluster, and port channel 30 go down to the servers. So let's look at port channel 20 configuration. So I have just a trunk. I have port channel 20 set up as a trunk and part of a VPC. And we have 1, 2, 3, 4, 5, 6. We have 6 interfaces that are part of that port channel 20. But we're only using 3.3, 3.4, 3.5, and 3.6. So 3, 3, 3, 4, 3, 5, 6. These are the 4 interfaces going over to the cluster. And then we have a port channel 12 and 13, which go 12 is a VPC from Sean and Gus on the cluster control side that go to Woody, and port channel 13 are from the same two nexus over to Abby. So if we look at 12 and 13, so port channel 12 is just an access VLAN 99. This is that 999999 subnet that is used for the control link, and 13 is the same thing. So we're using 117, 118, 119, 120 is part of that port channel. It's really 317, 18, 19, 20 are part of VLAN 99. The other nexus, same thing. So same VLANs, using the same priority. I want both of these to look like the route to the rest of the spanning tree network. Same VLANs created, using HSRP here between the two nexus. And the port channels, you have port channel 12 and 13 that are part of VLAN 99, and port channel 20, which is the data link port channel. And that is the configuration.